So now let's talk about using these half-angle formulas to help us calculate certain angles. Right? We can actually use these formulas to help us out if we recognize what's going on. For example, the sine of 15 degrees. Well, if we treat 15 degrees as the half angle of something else, we could use this formula right here in order to help us get the value. So what is 15 degrees half of? Well, that's right, it's 30 degrees, right? So this is like saying, let's take the sine of 30 degrees over 2. What does our formula tell us? Well, number one, plus or minus, 15 degrees is in the first quadrant, so we're going to get a positive value in front of our radical. Number two, 1 minus the cosine of the 30-degree angle is what we're going to put inside of our radical right here over 2. So the sine of 15 degrees is going to be the same as the positive square root of 1 minus whatever the cosine of 30 degrees is over 2. Well, we happen to know perfectly well what the cosine of 30 degrees is. That's 1 minus radical 3 over 2. All of that's over 2. Oh boy, so that means we've got a fraction within a fraction and 2 radicals mixed in. Fun, right? It's all right, it's not that bad. What we're going to do is we're going to multiply by 2 in the numerator and denominator to get rid of the complex fraction aspect of that. So I'm going to take 2 times 1 minus the square root of 3 over 2 and divide that by 2 times 2, right? As long as I multiply in the numerator and denominator by exactly the same value, I haven't really changed anything. So I've actually got now 2 minus the square root of 3 divided by 4. Well, we happen to know this rule that says if you take the radical of a fraction, it's the same thing as the fraction of the radical. So it's like saying we can take the square root of 2 minus the square root of 3 divided by the square root of 4. Now, the square root of 4 is 2. So in other words, our radical answer, our exact value form for the sine of 15 degrees, can be stated to be square root of 2 minus the square root of 3 all over 2. A radical within a radical exact value. How's that for fun, huh? How about this next one? Well, let's take a look at the cosine of pi over 8. Well, now we have to figure out, well, pi over 8, that's half of something, right? What is it half of? Well, pi over 8 would be the same thing as saying 1/2 times pi over 4, because if you remember, in fractions we multiply numerator to numerator and denominator to denominator. So 1/2 of pi over 4 is pi over 8. So we'll use that formulation right here. We're actually finding the cosine of our half angle being the half of pi over 4. So we're going to use this formula right here for cosine of alpha over 2, only this time we'll note that because alpha over 2 is in the first quadrant, pi over 8 is the first quadrant angle, we're going to use the positive in front of our radical again. And we'll take 1 minus the cosine of pi over 4, the angle that's not half, divided by 2. So that should be plus right here. All right, so what does this actually turn out to be? Let's work it out. Kind of similar to the last problem, we know that the cosine of pi over 4 is the square root of 2 over 2, and we're dividing that by 2 here. So what we're going to do is we're going to eliminate this complex fraction aspect just like we did in the last problem. The common denominator of all the fractions within the fractions is 2. So I'm going to take 2 times 1 plus the square root of 2 over 2. And that will be divided by 2 times 2. Well, what we're going to get right here is the square root of 2 plus the square root of 2. 2 in this denominator cancels, divided by 4. And just as before, we take the radical of a fraction to be the fraction of 2 different radicals. So this is going to become the square root of 2 plus the square root of 2, all divided by 2. So our cosine of the angle pi over 8, that's what it would be equal to as an exact value using our half angle formula. All right, how about this tangent? Well, tangent 105, let's figure out what is tangent 105 half of. Looks like if we were to multiply 105 times 2, we'd get 1/2 of 210 degrees. Which looks like we're going to have one of these fractions whose tangent is a fraction. So I'm going to use this formula again. I like this second formula right here. So we're actually taking the tangent of 210 degrees. We're taking half of that. So by that second formula, we're taking 1 minus whatever we would get from the cosine of 210 degrees and dividing that by the sine of 210 degrees. Okay, so now we have a little bit of a different problem. We have to figure out what the sine and cosine of 210 degrees is. Let me just come all the way down here and remember, we're in the third quadrant with 210 degrees. Third quadrant. Right? 210 degrees means come down around it to the second quadrant. That's past 180 degrees. Since we're in degrees, we take the difference of the larger angle minus the smaller angle to get our reference angle. So 210 degrees minus 180 degrees is going to result in a basic angle of 30 degrees. But we're in quadrant 3, so that makes sine and cosine both negative. So our formula, here's what it looks like now. 1 minus the cosine of the 30-degree reference angle is square root of 3 over 2, but it's a negative square root of 3 over 2. And we're dividing that by the sine of 210 degrees, and that's negative 1/2. Well, in effect, because we've got a single fraction down in the denominator, we can multiply by the reciprocal. So we're going to actually have 1 plus the square root of 3 over 2 times negative 2 over 1. And this is the kind of fraction that I can just simplify by using the distributive property. So I'm going to distribute negative 2 into the parentheses. I'm going to get negative 2 minus the square root of 3 over 2 times 2, so that's minus the square root of 3. And so this is the value of the tangent of 105 degrees by this formula. All right, more to come.